Okay, next one, let's look at the relationship between mutually exclusive events and what? Independent events. Is there any relationship between them? Okay? Mutually exclusive. Events compared to what? Independent events. Okay? Are there any relationship between them, or there is no relationship between them? Okay? What is a relationship between these two different concepts? Okay? Now, to explain their relationship, let's look at what? Another example. Let me call this is random experiment 6. We flip a fail coin once. If we flip a fail coin one time, what is the resulting sample space? Well, there are only two possible outcomes. Either we see a head or we see a tail. Nothing else. Okay? Head and tail. And we define what? EA is an event that we observe what? We observe a head. And that is to say, this is event of seeing a head. And event B, similarly define event B as we get what? We get a tail. So this event consists of what? One outcome. They are both what? Simple events. Okay? Only one possible outcome in the events. So the case is very simple. Okay? Very simple. Easy for us to make what? This discussion. Now next one. We know EA and EB. EA is an event that we see a head. EB is an event that we see a tail. Do they share anything in common? Head and tail. Do we see anything in common? No, they don't share anything in common. So what can we say about EA and B? EA and EB are mutually exclusive. EA and EB are mutually exclusive. They don't share anything in common. Are they independent? That's the next question. Are EA and EB mutually exclusive? Oh, sorry. Are EA and EB independent? That's the question we want to know. Are they independent or they are dependent? So let's see. To answer this question, let's check what? Let's check with the definition. The conditional probability of EA against what? The unconditional probability of EA. We want to know whether they are equal or they are not equal. Okay? I put a question mark here. Let me put a question mark here. Now, let's begin with what? The unconditional probability, EA. The probability of observing a what? A head. Since the given coin is a fail coin, this chance is 50%. Now, next, let's look at the conditional probability. Given that EB has occurred, what is the probability of EA? What is EB? EB is the event that we see a tail. If I tell you I see a tail, that means I don't see what? A head. Remember, we only flip the coin what? One time. So, if you tell me you see a tail, that means what? You don't see a head. So that is what? 0. Okay? And since 0 is not equal to what? 1/2. The conditional probability is not equal to the unconditional probability. That means these two events, they are what? they are not independent. Okay? So EA and EB are not independent. Not independent means they are what? Means they are dependent. That means they are dependent. Okay? EA and EB, they are dependent. Now, actually, they are not just dependent. Okay? Why are they are not just dependent? They are highly dependent on each other. Think about this. If you tell me you see a head, I know right away you did not see a tail. If you tell me you see a tail, I know right away you don't see what a head. They are not just dependent, they are highly dependent. This kind of dependent relationship we call what? Perfect. Dependency. That is to say, you tell me one, I know exactly what happened to the other one. Okay? So, what is the conclusion after we look at what? The example. The conclusion is that if A and B are mutually exclusive, or disjoint, that means A and B must be what? Must be dependent. One happen implies the other must what? Not happen. Okay? So it's not independent. So let me try one more time. What is a relationship among two mutually exclusive events or disjoint events? If A and B are mutually exclusive, then they must be what? Dependent. Okay? You want to copy? Go ahead.